Okay, guys, back here today with 17.5 simulation with random numbers. If you happen to be from the honors class, this would relate with 18.5. We're going to take a look at the key concept here to start things off with. And in essence, here's what we got. We got a quarterback who usually is completing about 60% of his passes. The action, the quarterback throws a pass. The sample space, there are two of them: complete pass, incomplete pass. Those are the only two things that can happen. And you want to set up a simulation, in essence, to see what transpires here. And so we're first of all going to assign numbers to the outcomes. We want to pay attention to 60%. So we need to be thinking about, how do I get an easy situation where I have 60%? And so they're saying, hey, why don't you let probability of complete be 0.6. Probability of incomplete then would be 1 minus 0.6. 1 minus 0.6, which is going to equal 0.4. Probably from your philosophy, you could think about this a little bit easier if you said, hey, we threw 100% of the passes, 60%, that would be the same thing as this 0.6. And the percent of incomplete would be 100% minus 60%, which is 40%, and the 40% connects to this 4/10. We are then going to assign digits 0 through 9. 0 through 9 is what we're going with. If you take a look at that, that represents 0 through 9 is 10 numbers, right? So 10 numbers represents, how is an easy way to get 6 out of 10. Think 6 out of 10. So that means that these first 6, okay, we're going to let, anytime you come up with a number 1, 2, 3, 4, 5, or 6, that represents the fact that in the simulation you completed the pass. And if you get a 7, 8, 9, or 0, then that represents an incomplete situation. If your question is why we're using 0 instead of 10, obviously the answer is because we're using one-digit numbers, if at all possible. Is this the only way you could have set it up? No. You could have said, hey, I'm going to use 100 numbers, and I'm going to let the first 60, 1 through 60, represent a complete pass, and I'm going to let 61 through 100, if you wanted to, or 61 through 99 plus 0 represent incomplete passes. We would then use random numbers to simulate it. So they chose, and I'll show you this a little bit later, a random number generator on the internet. They used a random number series. So they just went to something, randomly generated the following 6 numbers: 9, 2, 7, 6, 5, 0. And so from those 6 passes that they had, you can see that 1, 2, 3 of those passes were complete. So the simulation would mean, hey, 3 of the 6 passes were complete for 50%. So the simulation is closely related in this situation to the actual theoretical probability. All right? All right, let's move ahead then to part 1 and show you some examples here. Again, please pay attention to how we're going to pull this off. We've got a quiz that has multiple choice questions, 4 choices. So instantly you should be thinking, hey, 4 choices, and only one of those choices is correct. So you know that you're looking for to represent 1 out of 4. You could think of it as 25%. How else could I come up with? That would mean, by the way, that 3 out of 4 would be incorrect, or 75%. Please note 3 out of 4 plus 1 out of 4 is 4 out of 4, which is equal to 1. And 25% plus 75% is equal to 100%. All right? So any way we could show a 1 out of 4 situation? Well, the easiest thing that we could do, and I would try to stay easy here since this is a really new concept, you guys, we're going to use the numbers 1 through 4. We're going to have the number 1. Anytime the number 1 pops up, we're going to count it as correct. Anytime the numbers 2, 3, or 4 pop up, we're going to count as incorrect. So you could use this idea right here to represent that situation. If we take a look over here, use numbers 1 to 10. Well, if I use numbers 1 to 10, 1, 2, 3, 4, that would be 4 numbers. 5 through 10 would be 6 numbers. And so if we look at this and say, hey, that's 4 out of 10, then this is going to equate to 40%. All right? That's not going to work because we don't need 40%. We need 25%. So this one does not work. Coming over here, I've got 1 through 25. You have a total of 100 numbers. So 1 over 25, that's 25 total numbers. over 100 possible numbers, and boom, there you get my 25%. And so that means that 26 through 100, 26 through 100 would represent the other 75 numbers, and the other 75 numbers then would be 75%. So you could use any variation of that. This one would work, and this one would work. So those two would work. You could use 8, for example. You could say, hey, 1 and 2 represent correct answers, and you could say that 3, 4, 5, 6, 7, 8 would represent incorrect answers if you wanted to. So think of any fraction equivalent to 1 over 4, and you could use that type of variation. Again, I'd say, kids, keep it simple, stupid. All right, you want to make this as easy as possible for yourself with the fewest amount of numbers likely. Moving on to my next one, grocery bags. We're looking for 30%. As soon as you see this 30%, you guys should be thinking, all right, wait a second, 30%, what's the easiest way, fractionally speaking, to make 30%? The easiest way to do it is 3 over 10. Another way you could do it if you wanted to is 6 over 20. Another way you could do it would be 30 over 100, all right? But we would be smart, again, as I said, to use the easiest situation. So that means we want to say, hey, I want 10 bags. So here we go. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 bags. You can see of those 10 bags, we have these 3. So this one should work. All right. This one should work because we're indicating 3 of the people use their own bags. So that's 3 out of 10. So we're going to let the numbers 1, 2, and 3 to represent own bags. And we're going to represent other bags by using the numbers 4, 5, 6, 7, 8, 9, and 0. These other ones are not going to work. If you take a look at this dude right here, number 2, we're really in essence at 33 over 100, all right, which is 33%. 33% is not equal to 30%, okay? So we cannot use number 2. On this one, we have 10 bags in the first one, and we have 30 total bags. That would simplify to 1 over 3. 1 over 3 does not equal the 3 over 10 that we were looking for from here. All right, so this one also will not work. That means your answer should be just problem number 1. And you can see right here that that's exactly what pops up. All right, moving on here to part number 2. Now, part number 2, here we go again with a quarterback. Quarterback usually completes 60% of his passes, okay? Use numbers to represent possible outcomes. In this case, they're representing complete passes by using the numbers 1, 2, 3, 4, 5, and 6. Incomplete passes are represented by using 7, 8, 9, and 0. And in essence, we're going to drag down. We have 4 simulations taking place here. Each of them have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers, all right? And so we have to, on this first one, for example, we're going to say, each list of random use numbers to represent possible outcomes of 1 pass. Do I have a situation where we complete exactly 3 passes in a row? Do I have a situation where I complete at least 6 passes? Remember, the complete numbers are 1 through 6. So this works, this works, this works, this one works, this one works, this one works, and this one works. Is that correct? That is incorrect. Back up the train. I want numbers 1, 2, 3, 4, 5, 6. I'm sorry. So this works, this works, this works, this works, this works, and this works, as does this. So you can see in this situation we have what? 7 out of 10 complete. Okay, 7 out of 10 complete. Next one we have 4 works, 4 works, 3 is complete, 6 is complete, 3 is complete, 5 is complete. So in this situation we have 6 out of 10 work. We have a 1 is complete, represents complete, 5 represents complete, 4 represents complete, 4, 4, 3, and 6. So in this one we also have 7 out of 10. And on my last one, 2 is complete, 4s are complete, and that looks to be it. So this one is 4 out of 10. Now, by doing that, what we can do is we can say, hey, in which of these scenarios do we complete at least 6 passes? That's 6 or more. So the ones that are 6 or more should be the 3 that you see us having marked. Here's one of them. Here's another one of them, because we had exactly 6 out of 10 there. And here's another one, exactly 6 out of 10. In the purple section, excuse me, in the purple section, what we want is we want exactly 3 in a row. Here we have 4 in a row on my first one. On my second one, so that doesn't work. On my second one, looking downward, I have 5 in a row, so that one doesn't work. On this one right here, here's my 3 in a row, so that one works. And then here again we have 3 in a row, so that one should work. So the 2 that should work should be the 2 that are on the right. And again, these are just random simulated numbers, randomly generated numbers that they came up with. And this is where, if we were comparing each other's material, we're not all going to get the same answer in that situation because we don't all randomly generate the same numbers. So they're going to be forced on the homework, you're going to be forced to make sure that they're going to have to give you guys all the same numbers on the problem in order for you to figure this out. Last one on part 2, same situation, still talking about that quarterback. Complete, still 1, 2, 3, 4, 5, 6. Incomplete, still 7, 8, 9, 0. Which list of random numbers simulates completing more than 4 passes? So what we're looking for here is more than 4 passes in our event. So 1, 2, 3, 4, 5, 6. 4 is complete, 1 is complete, 1 is complete, 5 is complete. On my second one, 4 is complete, 3 is complete, 1 is complete, 1 is complete, 3 is complete. And then on the last one, 2 is complete, 6 is complete, 3 is complete, 6 is complete, 2 is complete. So how many did I complete in this case on the first one? It was 4. As you can count them up, the ones I have circled. On number 2, I have 5 that I completed. And on the last one, I have 6 that it looks like I completed. So which list of numbers simulates completing more than 4 passes? Looks to me like it's going to be all 3 of those. Oops, what did I do wrong? Oh, more than 4 passes, okay? So 4 is not more than 4, so we're not going to include the first one, all right? All right, moving on to part 3, last part here. If I take a look at part 3, this is where I'm going to bring on the last one. I'm going to bring up a random number generator. Actually, I'm going to do it on this one. So we have a 6-question multiple choice quiz. Each question has 4 choices. Only 1 choice is correct, okay? So this is going to take a lot of thinking on your part. First of all, you have 4 answers on each question. 4 answers for each question. So this should tell you, hey, no matter what happens, I'm going to go correct, and I'm going to say the correct one is a 1, and the incorrect could be represented by the numbers 2, 3, and 4. All right. It says you have 6 questions on the test, and you want to randomly simulate the quiz 20 times. So what you have to think about here is, hey, if I have 6 questions on the quiz and I want 20 quizzes generated, I have to generate 120 numbers. 120 numbers, all right? So I'm going to go ahead here quickly. I'm going to take you to what's called random.org. I'm going to go to another screen here, random.org. You can see it right here. We're going to scroll down on random.org, so I'd make sure that you knew or could find this particular website. And I'm going to go here to integer generator, all right, integer generator. And I'm going to click on that. And I'm going to basically set it up just like I told you. We're going to generate how many numbers? 120. Each number should have a value between what? 1 and 4, we said, to represent correct and incorrect. And then we want to format it. So think about how you want this formatted. You'd be smart to format this in 6 columns, because if you formatted it in 6 columns, you could read across the row. Each row then would represent 1 quiz. All right? So I'm going to go ahead and set this up as 6 columns, and I'm going to go ahead and hit Get Numbers. And so when I hit this Get Numbers, you can see the numbers that I pop up with. All right? So recall, in my situation, I've got, and I'm going to try to write this down somewhere, 1s represent correct. So if I take a look at the first quiz here, first quiz is the top row. First answer I got wrong, second answer I got wrong, third answer I got right, fourth answer wrong, fifth answer wrong, last answer right. How many questions did I get right on that quiz? 2. That's how we randomly generated it. Same thing on, let's look at quiz number 2. I'm looking at, got the first one wrong, second one wrong, third one wrong, fourth one I got right, so I only got 1 answer right there. If I look at the third, I'm going to continue to do this. So I got 2 right, I have 1 right, I have none right. So it's possible by guessing like that, I got none right on this one right here. Okay, I got none right on that row right there. Next one, I got this one right and this one right, so that's 2. Next one, I got none of them right either. On the next one, I got this one and this one, so I got 2 right. On the next one, I got none of them right. Look at this bad boy. I get the first 3 correct, and then I missed the last 3. First 2 correct, or not first 2, second, third. Got 2 correct, 2 correct, 2 correct. I got 3 of those right. Next row, I got 1 right. Next row, I got none right. Next row, I have just 1 right. Next one, I have 1 right. Next one, I have 2 right. Next one, I have 2 right. This one, I've got 1 right. And in this situation, I have just 1 right. So when we break it all down, did I ever get 6 of them correct? No. Did I ever get 5 of them correct? No. Did I ever get 4 of those correct on a guess? No, not based on my simulation. Did I ever get 3 of those correct? Yes, I did. I got 3 of those correct. Right here, I think that's the only 2. So 2 times I got 3 correct. Did I ever get 2 of them correct? I got a bunch of those. 1, 2, 3, 4, 5, 6. 1 of them right. 1, 2, 3, 4, 5, 6, 7. And then 0 of those correct. I have 1, 2, 3, 4. 4 of them. Now, if you did it right, since you have 20 simulations, this better add up to 20. I think I missed one there. So 4 and 7 is 11. 11 and 6 is 17. 17 and 2 is 19. I think I missed this 2 right here. Okay? So I'm going to go ahead and erase. I had 7 of them. That I had 2 of them right. All right? And so this is basically what they're looking for. If we take a look back at my screen, that's what they're going to be looking for. And again, if you did this on your simulation, your results are going to be different than mine. All right? Because you're generating different numbers than I am because it's random generation. All right? So let's roll back to Pearson. And in essence, I just filled in this entire chart right here. All right? And then based upon that chart, says use your results to complete the frequency table, which in essence is what I just got done doing. Good luck with everything. This will be a little bit tougher, a little more abstract than the last 3, 4 examples. Good luck.